Greetings from the Canadian border region of northern Minnesota. Today is Saturday, June 24th, 2017. We're looking out over Rainy Lake to Canada. The far shore there, about 2.5 miles away, is the southern shore of Canada on the lake, right by Fort Frances, Ontario. And today I'm going to be performing a experiment and test related to the pressure discussion. My name is George Nowchek, and I've constructed this apparatus here to aid in some of the discussion that's been taking place over the last few days on a YouTube hangout called Earth Discussions. The problem posed is in relation to the Bernoulli effect and what would happen if a uniform column of air is sent down a straight tube in which a hole is drilled in the sidewall of this tube. The question is would there be a negative pressure generated, a positive pressure generated, or no pressure generated at all in the opening of that hole? I'll now go over the apparatus and then perform a few tests. Okay, what I have here is a 75-inch pipe. To the far end I have a shop vac placed to push air down the pipe. The pipe is 75 inches long, and at the 67-inch point I have drilled a hole into the pipe and sealed a reinforced compressed air hose, which is 25 foot long. And at the other end I have a cover that I can place over this jar for an experiment. Or in this case, what I'm going to first do is I just happen to have a balloon attached to the end, and when I turn the shop vac on, air will be going down the tube, exiting here, and the question is whether or not there will be a positive or negative pressure generated at this point due to the laminar airflow down the tube. Well, by having this latex balloon at the end, if there's negative pressure, this balloon will get sucked dry, and if there's positive pressure, the balloon will fill up. So we'll look now and see what happens when I turn the shop vac on. Well, we can see that there was a very slight positive pressure being generated here. If I collapse the balloon, it blows right up, but it's not a very strong pressure. It definitely isn't a negative pressure. Negative pressure would be sucking the balloon dry and collapsing it, but instead we're getting a little bit of air being pushed into the balloon. There's quite a bit of airflow coming out of the tube. As you can see, if I hook the balloon up to the end, it blows right up. So there's quite a bit of airflow here. And again, I hook the balloon up to the hose.
blows
goes up, but the pressure isn't strong enough to hold the balloon up. It's very, very slight, but there's definitely a positive pressure. Well, we have our supervisor here. This is Con, and going to perform one more test. I'm going to blow much higher velocity air down the tube. In order to do that, I have now hooked up a gas-powered leaf blower. This thing's a real monster. It's capable of delivering and generating 180 mile-an-hour wind. So I now have it hooked up to the apparatus, and we'll get it started. It really makes a heck of a racket. You won't be able to hear me. I'll just be doing a little bit of demonstration and then explain what I have observed. So again, we have the balloon okay, here we go. Now, what I noticed with this very high velocity air is that the positive pressure generated really wasn't much greater than what we had with the lower velocity air. The balloon still would not stand up on its own. It was just appeared to be a little slightly greater than we had with the shop vac, because the balloon filled up a little quicker. It didn't take as much time to fill the balloon up, but it still didn't have much strength to hold the balloon up. So the conclusion here is that a negative pressure isn't being generated, and my guess is that under ideal conditions, if everything we truly had real good laminar flow, that there probably wouldn't be any pressure, positive or negative, being generated by the apparatus.